Hello students. In this video, we are venturing into one of my favorite topics, that is metabolism. Today we are starting with glucose metabolism, and this video is just part one because in this video we are only covering glycolysis. So now what is glycolysis? It is a process by which cell converts glucose into pyruvate. Now this can function under anaerobic conditions, and if it is functioning under anaerobic conditions, it gives us two final products, that is either lactate or ethanol. And even under aerobic conditions, for some cells like RBC or cells of or retina, and for cancer cells, this is the default pathway for glucose consumption. Now we'll get into all the steps in detail and how the process is regulated. So first, we start with glucose, and just like you have to invest some money to start your business and make more money, in the same way, first the cell has to invest some of its money, that is energy currency ATP, to get the process started. So ATP is used to phosphorylate glucose uh, by the enzyme hexokinase, and it gives us glucose 6 phosphate. We'll discuss the regulation of hexokinase in detail in another video. And for the now, we'll continue with the normal glycolysis process. Now, glucose 6 phosphate is converted into fructose 6 phosphate by enzyme phosphohexose isomerase. Now, this fructose 6 phosphate is again phosphorylated using ATP by enzyme PFK1, that is phosphofructokinase 1, to give us fructose 1,6 bisphosphate. Now, because the phosphate molecules are on two different places, it is called bis. But when two or more molecules are at the same site, they are called di or tri, just like ATP. Now about the enzyme phosphofructokinase 1. It is one of the main regulatory enzymes of glycolysis, and compounds like ATP and citrate, which are basically end products, they inhibit its activity, and compounds like AMP or fructose 2,6 bisphosphate, they increase its activity. Now, this fructose 1,6 bisphosphate is divided in two by the enzyme aldolase to give us a 2,3 carbon product, which both contain a single phosphate group. The products are dihydroxyacetone phosphate and glyceraldehyde 3 phosphate. Now, out of these two, dihydroxyacetone phosphate is converted to the second molecule of glyceraldehyde 3 phosphate by enzyme triose phosphate isomerase, so that we have two molecules of glyceraldehyde 3 phosphate. Now, this glyceraldehyde 3 phosphate is converted to 1,3 bisphosphoglycerate. And here the phosphate is coming from inorganic phosphate, and the cell is not using ATP. And this is the place where NAD is converted to NADH plus. If the cell is operating under anaerobic condition, then it can derive further ATP from this NADH. Now this 1,3 bisphosphoglycerate is converted to 3-phosphoglycerate by the enzyme phosphoglycerate kinase. Now this enzyme is named after the reverse reaction, and in this step one ATP is generated from ADP, and since we have two molecules of glyceraldehyde 3 phosphate, that means two ATP molecules will be generated. Now this 3-phosphoglycerate is converted to 2-phosphoglycerate by the enzyme phosphoglycerate mutase. This 2-phosphoglycerate is converted to phosphoenol pyruvate by the enzyme enolase, and phosphoenol pyruvate is dephosphorylated and dehydrogenated to give us pyruvate. And this is the second step where we get 2 ATP. So, for one molecule of glucose, we invested 2 ATP at the beginning, and then we got 4 ATP in return. So that means we got a profit of 2 ATPs for one molecule of glucose. Now, this last reaction is catalyzed by the enzyme pyruvate kinase, and this enzyme is also plays a role in regulation. This enzyme is inhibited by compounds like ATP acetyl CoA and long chain fatty acids. All of these compounds in high concentration suggest that cell has enough ATP, enough energy, and there is no further need to break down glucose. Now we'll check out some questions. Okay, before that, what happens with the pyruvate? So, as we discussed at the start of the video, pyruvate has two final options. First is lactate, conversion to lactate, catalyzed by lactate dehydrogenase. And the second path is decarboxylation by pyruvate decarboxylase to yield acetaldehyde, which is again hydrogenated to give ethanol catalyzed by alcohol dehydrogenase. Now, why are these products formed? So, if under aerobic conditions, the NADH is reoxidized through electron transport chain, which has oxygen as a final electron receptor. But under anaerobic conditions, there is no oxygen, so electron transport chain can't operate. But NAD is required for further glycolysis. So, to regenerate NAD, the hydrogen atoms are transferred to pyruvate itself to yield either lactate or ethanol. This way, cell can keep regenerating NAD even in the absence of oxygen. Now, let's look at some questions. So, the first question is, in a mammalian cell undergoing active glycolysis, what would be the effect of a sudden increase in the concentration of metabolites AMP, citrate, ATP, and glucose 6 phosphate? Now we are given four situations. A. Increased ATP inhibits glycolysis. B. Increased AMP stimulates glycolysis. C. Increased citrate and glucose 6 phosphate stimulate glycolysis. And D. Increased AMP and citrate inhibit glycolysis. Now, out of four options, which one is the correct combination of the statements? So, from whatever we studied in this video, let's look at all four compounds one by one. First is AMP. It stimulates the activity of PFK1. Okay, so B is correct. And then citrate, it inhibits the activity of PFK1. So D is wrong because AMP doesn't inhibit glycolysis. So we have our 50-50 lifeline here. The options 1 and 2 are out of the window. Now ATP, increased ATP will inhibit glycolysis by inhibiting the activity of PFK1. So situation A is also correct. And finally, glucose 6 phosphate. So it inhibits the first enzyme, that is hexokinase 1. So the situation C, that is increased citrate and glucose 6 phosphate stimulates glycolysis, that is also wrong. So the correct ones are A and B. Extra ATP will inhibit glycolysis because cells already has enough energy, and It doesn't need to break down extra glucose, and increased AMP means that ATP stores are very low and glycolysis is required for further ATP production. So the correct answer will be option 3, A and B. Now, second question. In mature erythrocytes, the end product of glycolysis that contains the carbons of glucose is option 1, ethanol, option 2, pyruvate, option 3, acetaldehyde, and option 4, lactate. Now let's consider these answers one by one. First is ethanol. Now, if this was true, we all would be drunk all the time, but that doesn't happen, and not naturally at least. So, option 1 is wrong. Now, option 2 and 3, pyruvate and acetaldehyde, they are not a final product because a final product is either ethanol or lactate. So, by this logic, the only correct option is option 4, lactate. Now, in future videos, we'll discuss gluconeogenesis, that is the synthesis of glucose in the liver, and then the regulation of glucose metabolism at hormonal levels, and also glycogen breakdown. Thank you for watching.